Welcome to Aerotech's Automation1 Motion Control Platform Educational Series. Aerotech is a company that solves your toughest precision motion and automation challenges. Automation1 is a motion control platform consisting of software-based controls and development tools, PC and drive-based control hardware, and hardware-based drives for servo motors and other devices. In this video, we'll take a look at Aeroscript data types and functions with a focus on basic and advanced data types, data type conversion, and function examples where we use different data types to accomplish different tasks that are quite common in the automation sphere. Begin with basic data types: integers, reals, strings, axis, and handle. On the screen now is the develop workspace in Automation1 Studio. We'll work through a simple example for each of the variable types that we're going to discuss. So, all variable types always start with var as part of their definition, and then all variables require a dollar at the start of their name. So in this case we'll start with a integer value, so we're going to call this my integer. Simple as that really, that's the name of it, and then we have as, and then we have the keyword integer. And you can see the IntelliSense is helping me out here and filling these things in. This is a valid variable, and this will initialize to 0, or I can choose to initialize it to a value, in this case 100. And this is a 64-bit. Second one we're going to do today, again var, and this time we'll do my real. So once again as a real, and you can see it pop straight up on the screen, and we'll put this equal to 66.666. Simple as that. A real is a real number, so it's a decimal number, also known as a floating point. Now, all of these are 64-bit floating points. And next we have the string. So we start as usual with var $, my string, as string. Now, good practice is to set the length of the string at this point, so we put in a set of brackets, and then we define how long this string will need to be. The reason for this is that the memory is allocated at the compile time and cannot be then reset while the program is running. That's because that will be a non-deterministic process. So in this case we're going to say that the string is 12 characters long, and we're going to set it equal to hello world, which is 11 characters. Now, during the program, we could change how long the data within this string actually is. So, they're the three classic data types, and now we'll move on to a couple of special ones. So, another variable is an axis variable. Now, on the screen at the bottom, you can see I have 5 axes defined: X, Y, Z, U, A. This allows you to give an alias name to the axis that you want to use. So this is very, very useful if you want to command axes that may well change in their designations, but you still want to run the same code. So my axis as an axis, and then we're going to initialize this one with the X axis. You can see there it's chosen the X axis. Now if I call, say, the home command with $my axis as the variable, then it would home the X axis. This is going to come in handy a little bit later in this video. So the final one is going to be a handle. Now, these are specifically useful for dealing with different files. So my file as handle, and then we just leave it at that for now. So when we want to load in a file, we put it into the handle data type, and then we can do different sort of file transitions on it. We'll do a very small example of that a little bit later in this video, and there is a full video on how to deal with files. That's it for the 5 basic data types. We'll now move on to the more advanced types, and also how you can make arrays out of these basic types. Now for advanced data types, which are structures, enumerations, and arrays. We will begin with arrays. Now, arrays are used to store multiple values of the same data type, and the data type used by the array can be any existing data type. So you can have an array of strings, or an array of integers, or an array of axes even, which is a particularly useful feature of Aeroscript. To define an array is very, very simple. So we'll do the usual In this case, we'll do a myInt array, and then we add a square bracket, and then we can add how many positions in the array do we need. In this case, we'll do 3, and we'll call this integer. Now, we can then add in the values for that array. So we can put an equals, and then we can give the 3 values. Please do notice that when you put an open bracket, we automatically add in the closed bracket for you, just to save you a little bit of time. So the myInt array is 3 values long. So in this case, we'll just do 1, 2, and 3. And you can see there's no errors. We're always going to have warnings because we're not using any of these variables. Equally, if you want to, you can do a 2-dimensional or a 3-dimensional array. Now you can do lots of different things with arrays anyway, so we'll do var my, in this case we'll do real 2D, and we'll open the bracket and we'll do, in this case, a 4x4 matrix as real, and then we can actually set up the value here, or we could just leave it as an array without having the data there. We could add the data in later. So this would allow you to do a variety of different things. One thing you could use a 2-dimensional array is you could use it and put in different sets of gains to then be loaded in as part of a program. For now, we will just leave this as a defined variable and move on. Another useful feature of an array is that we can make an array of axes. Now, this is very, very useful, and a lot of the Aeroscript commands make use of axes so that you can do multiple commands at the same time effectively, or so you can coordinate multiple sets of axes. So a lot of my example programs will have an all axes variable, which will be an array as an axis, and within that array I will just add in x, y, z, u, a in this particular case. This is a really, really useful feature to do. So you can see here this is going to be a dynamic array, so what we're going to do is just put an equals in there, and then the definition is complete. And you can see we can now build that. One of the most useful things about this is, just for an example, if I use home, you can see the tooltip when I put in the home command brings me axis and axis. If I press the down arrow key, you can see axes as an array, as an axis, so that's an array of axis. That allows me then to pass the whole of the all axes array and then run this function on the array. That makes it much, much faster to tell multiple different sets of axes to do the same thing, so in this case to home them all, but also if you were doing a move linear, you could then do a coordinated motion of all of them. Moving on from there, we will take a look at the structure data type. Now, this is particularly useful for doing a variety of different things. You might have some different settings that you want to put in all into one place where you know where they are. So a structure is an aggregate data type, or struct for short, and it's user defined. So it's useful for grouping common set of data. So it might be the gains for an axis, or the coefficients for a filter, or really any sort of data that you want to use. So to define one of these, we do struct, and then in this case we're going to call it axis data. Now you'll see, because we've started the struct, when we've hit return in this case, we're actually indented slightly. So then we can do a series of values. So we'll do pos as real, vel as another real, just need to put it onto a separate line. We'll do ac as another real, and then we'll add in some miscellaneous data. In this case we'll do misc data, and then we'll put this into an array even. So there we go, and that'll be an integer. And then all we need to do is end the structure. So if you just type in end in this particular case, and you can see there the little bit of a grabber has appeared so that we can open and close this if we wish to. So we'll also put that back on. So there you go. That's how you can define a struct that you could then call and put in different pieces of data. There is a full set of examples within the help file and also the Aeroscript programming reference. Now, our final data type for today will be the enum, or enumeration. So what is an enum? Well, an enum is enumerated data type, and it's a data type that consists of a set of named values. They're called enumerators, but the main purpose of an enum is to perform logic using a set of names rather than using constant numeric values. Why is this useful? Well, this is part of the object-orientated part of the Aeroscript language, but it is incredibly useful when we look at different parts of an axis. So if we want to look at some axis data, we will use the enumerations to get the correct value from them, which is where we're going to create an example using that. Now, to define an enum, a very, very simple one might be enum direction, and we might want to do north equal to 0, south equal to 1, east equal to 2, and west equal to 3. That's a very, very simple one. Now, if we wanted to, the numbering would happen by itself, but we can also set that numbering when we want to. So it would be perfectly valid to, instead of having the 0, 1, 2, 3, to have none of them be defined at all. But it really is an all or nothing on that one. Now that's just how to define one. If we want to actually make use of some, in this case we'll take a look at one of my personal favourites, which is the status get axis item. This is a very, very useful command. This allows you to read back any of the variables that are associated with an axis, and it's how we access a lot of different data that's sort of hidden away underneath everything. So status get axis item, we'll open this up, and in this case we're going to choose the x-axis, and then we have this option here. Now as you can see on the tooltip, it's $status item as axis status item. Now when you see one of these, it's highly likely that that is an enumeration. Now if I just start typing in axis status item, you will see it pops up on the screen, and this little symbol to the left of these is the enum symbol. So you can see the extra tooltips come up saying enum axis status represents an axis status. Axis status item represents an axis-based status item that can be retrieved from the Automation1 controller, and that's the one we're going to use. We've already highlighted it using the arrow keys, and I'm just going to press the full stop. So then it comes up with the variety of different variables that we can claim back. Now this really saves you having to mess with numbers and having to remember those numbers. It's all in words. Makes life very easy. I could choose any one of these. There are several hundred of them in fact, and there's a full listing of them in the enum part of the help file. In this particular case, I'm going to take the position command, or we could take even the position error or the position feedback. In this case, we'll have the position feedback. I could save that then into one of my already defined data types. So in this case, we'll take the myReal. So we'll do $myReal and make it equal to status get axis item. So there you go. That's a very, very quick way to use enums, and it's a very useful way to use enums. Data type conversion. To begin with, we're going to go into the help file. In here we do have an example program that's set up to demonstrate lots of the different types of conversion that we can do. So the quickest way to talk through an example here will be to use this. Now we can just hit the copy button on the top, and then we can paste this into a document, a Aeroscript file. So you can see there's quite a lot here, so we're going to focus really on talking through what different functions can do. We do have in Aeroscript most of the standard types of conversion that you would expect. So we can do axis to string, integer to string, real to string. These are all quite commonly used. Now, obviously with string conversions, you may be reading a file in and then converting the value that you brought in from a string to a number, or you may be going the other way. So you may, on the app message display, or any messaging you want to put into your system, you may want to convert one of your number variables into a string. That's why we have the integer to string and real to string. So we can go both ways. As we come down here, we can see there are various different sections here. Here we do string to real, So 123.4, and then if the real is 123.4, then it will display a message for you. Equally, we do string to integer where we go the other way. Another little thing that you can do is if you have the name of an axis as a string, in this case the y-axis, you could then put an axis equal to a string using the ampersand or the @ sign as it's commonly known. So that's a neat little trick that you can use when you want to disable axes. So it might be that you write a little subroutine, you get a menu up saying deal with axis y. This allows you to do a very simple conversion there. As we come down here, we've got lots of different examples, and I advise that you work through this example program and just understand what's happening. Now, of course, when we convert a floating point number, a real number, into an integer, we will have two separate segments to that. There will be a fractional part and a truncated part. So with that one, you then have to deal with the two halves of it. So you can see here, my integer is the truncated 567.8. Coming down a bit further, there's a few more of those as well, so rounding a real value to the correct way as well. Of course, most of the most common conversions that you might want to do are quite easily named. So if we just skip into the middle here, if we wanted to do integer to string, we can just type in integer and already integer to string came up there. Integer to string has popped straight up on the screen for us to make our lives quite easy. Equally, when we do it into an @message display, you can even do it as part of the whole message, so there's no need to do the calculation separately if you don't have to. So you can see here, fractional value equals is all in quotes, plus real to string to give you the string. Best thing to do is to open up the example and to have a look through the different options that you have, but most commonly needed conversions are going to be available within Aeroscript. We'll now take a look at a function example, reading and converting a file. Our first example for this video will be reading a file. So this may well be a file for any sort of reason, but today we're going to look at a CSV file. So we have a comma delimited text file, which has got two strings of numbers in. We have been given this by a customer, and we need to pass this data into an array that will then form part of a test trajectory. So this is an ideal example for what we need to do here. I do have this pre-written, so we're going to write this line by line, and we're going to set up a series of variables that will be needed to start with. Now, the first, of course, is going to be the trajectory itself. So we're going to need to put the trajectory file into the system. To do this, we will use a handle. When we import the file, it will go straight into the my trajectory file variable. So I'm going to just copy a comment across now. I'm going to build this program up section by section, so I'll keep going back to the top to add in extra variables, and this is quite a common way for me personally to code. Nice thing is, I don't have to type in my trajectory file total, I can just put part of it in. We can then do file, and we'll use the open text variable, and then we're going to put in the file name, in this case is loading profile underscore csv.txt. Now, this file needs to be within the controller file system, so please watch the files video for a little bit more information of how you need to deal with this. And then the next thing is, what are we going to do? Are we going to read or are we going to write? You can see on the screen, we've got another one of those Enums. File mode is right there. So if we type in file mode, we have an enum and we're going to read it. There we go, that's it. It's as easy as that. That is the simple command that we need to use. We've imported our text file into a handle. Fantastic, that means it's now within Aeroscript and we can manipulate it. There are various different ways to create a loop to go through this. We're going to loop through the file line by line. We're going to import each line, and then we're going to split each line into separate strings. What we'll then do is loop through another set to go through and do the string to real commands. So this is really a combination of lots of different elements that we've been through today. We're going to do a while loop. Now, I happen to know that there is a command that's very, very handy for doing this. So, is the file at the end of the file? I took this as inspiration outside of the help file. And then we need to put the handle in there, so $my trajectory, there we go. And then we'll do not equal to 1, because with this particular variable, it will turn to 1 when it's at the end of the file. So there we go, that's a nice little one. And just for completeness' sake, we'll put an end in here to the end of the while loop, just to make things nice and clear for us. We're going to need to define a couple of variables here because we have to iterate through each line of this file. Now I know what this file looks like. This is a very, very simple file. Each line has 2 values on it. So we're going to use a couple of really, really simple to use commands for doing this, and we're going to read in the line and then we're going to do a split on it. So I'm just going to put in a couple of holding variables, and we'll leave these as just basic strings and then they'll just get used in this particular case. Inside the while loop we'll do $s, and we're going to do a file text read line. So we're going to read in the file, we're going to give it the handle, my trajectory file. That will read in the first line, and then we are going to do what's called a split string in this particular case. I'm also just going to set up another variable here. I just want a few integers that will then come in handy for what we are going to be doing. I'm going to need one that in this case is going to be called string num. There we go. Oh, I've missed off the $, so we'll just add that. You can see it didn't recognize it. It's got to be this nice dark blue color, and then we'll go string num is equal to, and this is a really, really fun command. This is the string split command. What we will be doing, we'll open it up. The IntelliSense is already telling us what we're going to need to do. So we know, okay, we need to give it the string as the input. That is going to be the line that we've already taken in. We need to define the delimiter. You could have multiple delimiters in this. In this particular case, we know that it is just a comma. You can see it's got to go into square brackets. And then we have to say where the substrings are going to go. So in this case, they're going to go into SS. And SS will need to be an array. So you can see just up here, I've just made that an array of size 2. So there we go. That will do the split for us. The next thing we have to do is convert each of the values within SS into a real number. So of course we're going to need a variable for that. In this case, we'll just call it trajectory, and then this is going to be a 2x2 array because I'm going to have 2 values to bring in. So this might well be, I don't know, 100 lines, say, and it's going to be 2 wide, and it's going to be a real. We are on this line importing the string, and on the next line we are going to split that string. The next line down then is that we need to do the conversion. So we have an array of strings, and now we're going to do a quick little conversion of the values. In this case, we're going to need to define a row. Now, just thinking about this, if I'm going to loop through this multiple times, the quickest way to do this will be to have a loop variable in there, something that counts the loop for us. So I'm going to call mine loop num, and we'll have to add that onto the top. So defining another integer, $loop num, $loop num, and then we need to also put in which part of the array it's going to be, and then we do the string to real. There we go. Open the bracket, and then we need to pass it the data. So in this particular case, it's going to be the first part of the SS array. We have, of course, as we've already said, got 2 values. So we will copy the line and just add in the extra variable. Now, if this was a really, really big array, I'd do a loop in a loop to do all these conversions for me. But for 2 lines, it's quick enough to do it this way. And then we do loop num, and I'm going to use an old classic of putting ++ on it. Anybody familiar with C will know that one. So that just increments the loop number, and then we have the end line comes after that. And there we go. It is as simple as that. The only other thing to do is to close that file that we've created. So we'll just put file close my trajectory file. There we go. That is a very, very quick example for importing a file and then using some string manipulation functions and converting it into real. So you can see it's not very many lines of code. It's maybe 10 to 15 actual lines of action here with a few comments thrown in there. Now we'll move on to the next example. We'll now take a look at a function example, reading and converting a file. Our next example is going to be a home conditional. So sometimes when you want to home an axis, you want to make sure it's at home, but not actually go through the homing routine if you don't need to. So it might be the x-axis was already homed, but my program always says home the x-axis just in case there's been a reset or anything. There is no standard Aeroscript command for doing this at the moment, but what we can do is write our own little function for doing so. To do this, we're going to just set up a basic little program block here, and it's just going to, in this particular case, do enable x. Now, what we will do is set up a variable at the top that will be all axes. It's one of my personal favorites, of course. X, Y, Z, U, A. There we go. So now, if I put in, instead of just enable, if I put in $all axes, this will now enable all the axes in one go. We can see, I just need to put add axis, and then we go hit play on that, and it will turn it on. It's just turned everything on for us, so that's absolutely fine. We can just turn all these off. I could just put a disable command in, of course, but I'm not going to do that today. We are going to create a new function. To do this, we type in function, and we will call it my home. What we're going to do is we're going to pass it a variable, which in this case is going to be $axis as axis. There we go. So that means we can then call it my home with an axis within it. And then, as I like to do, I'm going to add in the end function. What are we going to do? Well, we need to do a very, very simple thing of, it's going to be an if statement. Handy little thing about Aeroscript is it knows what an if statement is. If I double hit tab, it will then put in a little bit of a code snippet for me. It's not if true. In this case, it's going to be if the status item is not already homed. We're going to do status get axis item. We are going to then choose our axis. We're then going to look at the axis status items again. So I'd used this a little earlier on in this video, and in this particular case we're going to go for the axis status one. Axis status is a little bit different because axis status itself is an enumeration. You can see here, when I've added the comma, it's immediately said additional data as integer. I could go into the help file, I could find the number for what I want to use and then put it in here. However, that's going to take me a little while, and to be quite frank with you, I am a little bit lazy. However, there's an enum for this. Axis status is the enum. I can hit dot, and then you can see \active, enabling all the different things, and you can see there's a homed bit. And then all we do is we go not equal to 1. Just to run through the logic of this, so we're looking at status get axis item. We're looking at the axis that we pass to our function. We're then going to do axis status item, axis status, and then we're going to do axis status dot homed. So that is the home bit of the axis status enum. And if it's not equal to 1, because when it's equal to 1, it's homed. Just to see this running, what we're going to do is add in an at message display output. These are really, really handy if you need to debug or need to just see what's going on. We know that if it goes into here, it is in fact going to home. We're going to hit play, and then we're also going to need to call the function. So my home, and in this case we're just going to pass the x-axis. Nice and easy. We're going to hit play, and you can see it's now homing, so it's gone to homed. Wait for that to clear, and then we'll run it again, and if we don't get the homing message, we know that it didn't need to home. Press stop, press play again, and you can see it's just jumped straight to the end, no messing around. So there we go. That is a really quick single axis conditional home. Of course, you might want to pass an entire array of axes to it. Now, the rather handy thing about modern programming languages is the overloads. We can give a function multiple meanings. Now, you've already seen this a few times. In this case, we're going to do a second version of this. It's got the same starting point, but it now has a set of overloads to work through. We already know that this piece of code works really quite nicely. We are going to copy it down, but we will need an additional loop in this particular case because we're going to pass an array, so there's going to be a lot of different elements to it. In this particular case, we can use the for each command. For each var item in array, the array in this case will be $axes, and just to make life easy, I'm going to use axis again, and I'm then going to take my if statement and put it inside that loop. Now I just want to correct the tabbing to make this easy to read, so then you can see where each of the loops is. So you can see the for each axis in axes, that's what we've passed into the function. We do if status get axis item, looks at the item. If it's not homed, it then says that it needs to home. And what we're going to do as well is just do another little trick here, which will be just to say which of the axes is homing. So axis to string in this particular case, open it up, and we're going to add in axis. So there we go. Instead of doing my home on X, we're going to do my home on all axes. And I'm going to open up the notifications. So the messaging came through here last time. It will come up across the top of the screen when we run as well. And I'm just going to hit play. I've got an error. So we'll have a quick look to see where the error is. Oh, yes, I've missed out a bracket. And then we can hit play. And you can see here it's homing Y, homing Z, homing U, homing A, but it didn't home X because X has already been homed. So there you go. That is how to write a home conditional using the inbuilt functions, enumerations, and an overload on a set of functions. The only additional thing we could do here is to put this into a library file so that then you could always use these no matter what else is happening. And to do that is a very, very simple task. All we have to do is put them into a library file. So why don't we just do that? New library file. We're going to copy everything that's there. Normally, as part of this process, I would put in lots of comments. Just for speed today, I'm not going to. So we've got there, library functions. We'll do a save as, and we'll do it. So we'll say cc homes, and we're going to make sure it's saving as a library file. So we'll save that, and then we'll compile it. That's very, very important to do. Going to go into Program Automation, compiled libraries, and add that library file that we have just created. And we'll have it as an auto import, and we'll hit save. So now, interestingly, we've defined these ambiguously, and that's because we're looking into a compiled file. But when I run these, we still go through, and it's now homing all of the axes. So there you go. That is a home conditional using a lot of what we've discussed today, and then also making it into a library, meaning that you could put that file onto every one of your machines. Equally, you could build up other different examples as you go. That concludes this Automation 1 educational video. Thank you for watching. I hope you enjoyed learning about Aeroscript data types, functions, and overloads.